Hi, this is a video blog about the kinematics of crouch gait. It's got some really interesting and counterintuitive results. At least I find them interesting. They'll be particularly relevant to those of you with an understanding of CP gait, but I thought others will find them interesting as well. If you want to follow this, you can go onto my blog site, select the Vern page, and move down to the third version of Vern down here. So this is Vern. He's basically a sagittal plane model of a human. The relative lengths of the segments equate roughly to the average human as well. And it's got two modes. One of these, using the top button, allows you to investigate clearance, and the other one, a little bit lower down, allows you to investigate step length. When you click the step length button, it puts Vern in the pose of the average person at foot contact. Given that the feet don't generally move after contact has been made, then step length is obviously going to be determined by the distance that the leading foot, the right foot, is in front of the trailing foot in red at that particular time. Now we can interact with this animation. If we drag on the segments, they will rotate about the joint. So if I drag on the tibia, it'll rotate about the ankle. If I drag on the femur, it'll rotate about the knee. If I drag on the trunk, it'll rotate about the hip. And you can see that it's working in this particular fashion. You'll also see that I do this, the figures on the graph change as well, so I can read off that that is the hip in exactly 79 degrees of flexion. If I get too out of sorts, I can then press on step length to get the character back to where he was starting. The other thing is, if I actually hold the control button down at the same time as dragging, then the relative orientation of all the segments stay the same, apart from the segment I'm actually dragging on that can be useful at times. You'll notice that there's a green line vertically down the page, and this is always going through the heel joint of Vern. If I flex his hip a little bit, you'll see that the reference line stays in grey in the background, and if Vern has got a step length of greater than this, then the vertical line will be green, and if he's got a step length of less than this, then the vertical line will be red. Now we can have a look at some of the simple things that are really intuitive, and of course Vern behaves exactly as you might expect. If we flex the leading knee, okay, by a few degrees, you'll see basically the step length is quite a lot shorter than it would have been otherwise. If we restore that, we can actually flex the leading hip. You'll see that we then have to apply a little bit of compensation, either at the ankle or the foot, which allows the foot to come in contact with the ground, but now Vern's got a step that's considerably greater than it was in the normal position. But one of the interesting things I found about was investigating what happens when you flex the trailing knee. So let's just have a pause to allow you to think. Is the step length going to get longer or shorter if I flex the trailing knee? If you want a bit more time, you can actually pause the video and think about it. Okay, so I'm going to do it now. I'm going to flex the trailing knee, and you can see as I flex the knee, it lifts the foot up and brings it forwards. And if I then also apply a little bit of heel raise to allow the foot to come down to the ground, you'll see that the trailing knee flexion has actually increased step length quite considerably. I wasn't expecting this at all, but I've since done a little bit of mathematics on it, and it turns out that, as near as damn it, the amount by which step length is increased by each degree of trailing knee flexion is almost exactly the same as the amount of step length that is decreased by leading knee flexion. Which leads to some interesting consequences for crouch gait. So, for example, let's assume that this person is going to have 10 degrees more knee flexion than the normal person at initial contact. So at the moment it's 6, and I'm going to move this up to 16. And you can see that the step length has reduced quite considerably. But I'm then also going to increase the trailing knee flexion from 13 up to 23, if I can control it properly. Okay, and then going to allow the foot to drop onto the ground. And you can see that the step length is almost exactly the same as it was in the normal pose. So one thing we can see for this is that crouch gait, although it appears to limit step length when you're looking simply at the leading limb, if you take into account what's a symmetrical effect on the trailing limb as well, it has virtually no effect on step length. Now, once I'd seen this, it occurred to me that although the step length may be unaffected by crouch gait, it almost certainly makes clearance more difficult. And again, maybe you'd like to take a few seconds to persuade yourself of this. But with Vern, of course, we can actually go and investigate this. So I'm going to tap him into clearance mode. Okay, and what happens here is that you'll see that basically the line is now a horizontal line, and it goes green if the foot is clearing the ground, and it goes red if the foot is colliding with the ground. And what I want to show you first of all is that actually if we want to get clearance by knee flexion alone, we have to use a hell of a lot of it. So you'll see that if I just flex my knee, because of the way the foot is sticking out at the front, it actually ends up in all sorts of clearance problems. And what you'll find is that in order to get true clearance, I've doing it a little bit too much, in order to get clearance by the knee alone, I need to get around about 50 degrees of knee flexion. And the bottom line here is that if you want to use your knee to get clearance, you've got to use a lot of it. Having a small amount of knee flexion actually makes things worse. Let's just show you that. Let's go to 30 degrees of knee flexion. And you'll see that when I swing through, I'm actually worse off than I was with a fully extended knee. So let's think about our patient who's in a little bit of crouch. Let's pose both knees in about 30 degrees of crouch. Take me a little bit of time to get this sorted. I'm going to drag him forwards a little bit upright, coming through. Okay. And I think we need to do just a little bit. I'll just make him symmetrical. Okay. So we're in around about 30 degrees of crouch gait. And you'll see now, actually, I can very nearly swing the leg through without doing any more knee flexion at all. And if I just flex the knee by a very small amount, by 3 or 4 degrees, let's move him up from, I think it was 30 degrees to just under 40 degrees. And you can see that I'm now getting nice clearance with a very small amount of knee flexion range. We've gone from 30 degrees to 39 degrees on the right. And actually the total amount of knee flexion I need here is less than I need if my supporting limb is fully extended. Now, I'm not suggesting that walking in crouch is a good thing, but the predictions of this model suggest that for children with a limited range of joint motion, particularly at the knee, it may have some advantages that we've not so far been aware of. It supports a general view I've got that many of the patients we see are walking in a way best suited to their pathology, rather than being examples of walking that is itself pathological.